Okay, so today we're going to do my first flipped lecture on dimensional analysis. So I'm going to do my lecture in Cornell note form. You do not have to do it this way, but I like to take notes this way, so that's how I'm going to set it up. Okay, so make sure your notes are labeled with what unit we're in, what chapter we're in. So we're in Unit 1, Chapter 1. Please record the date. Today is the 22nd of August, and today our objective is students will be able to, so that's what the SWBAT stands for, convert between units using dimensional analysis. And I always do want you to write your objective on your notes because it helps you to know what you took notes on, okay? Key. So we're going to start off with why do we care about dimensional analysis, okay? Why do we need it? Well, in chemistry, we study matter and we study its changes. And so basically, we need to be able to numerically show or represent how much matter we have. Okay, so to do that, we have to, well, first we have to measure matter, right? And then once we've measured the matter, we need to record how much of it we have and in what unit we measured it in order to quantify how much of matter we have. Okay, so basically, we need to be able to then at some point in time convert between units because there are so many different units that chemists use for representing how much matter you have. And it also depends on what state of matter you have, right? So volume may measure how much liquid you have in milliliters, but it could measure how much solid you have in centimeters cubed. Okay, there's also the huge thing in the United States where we use standard, but the language of science is metric. So please get used to using metric units. You do have an assignment on that this weekend. Okay, so we need to convert between those units so we can have an accurate comparison of how much matter we have, depending on what we measured it in and what we want to know about it, okay? Okay, so next we're going to talk about what is a conversion factor, okay? Here I have one of the conversion factors you're going to use the most. Basically what it is it sets up an equality between different quantities of with different units. Okay, so for example, you are going to use this one a lot in AP Chemistry, the conversion that 1,000 milliliters equals 1 liters. Okay, so this is my little therefore sign. It's 3 dots in a triangle. It's a mathematics sign, but I use it in my shortcut for note taking. So basically, if these guys are equal, you can put either one in the numerator or the denominator. Okay, you can put the milliliters in the numerator or the liters in the denominator and backwards, but essentially they both, since they're equal, right, this over this, since they're equal, it equals 1, right? The same idea that if you had smiley face over smiley face, that's equal to 1 because they are equal to each other, okay? So basically when you're doing dimensional analysis, you're effectively multiplying by 1 to convert between different units. And again, we need to convert between units for comparison of how much matter we have depending on how that matter was measured. Okay, so we're going to do an example here of how many liters are in a 437 milliliter sample of hydrochloric acid. Okay, so all dimensional analysis problems will turn into what is given. So you're going to have a number and a unit there. And then what unit do you want to find? So you will be given a number and a unit, you will be told what unit you want to find, and you have to basically find a number associated with the new unit. Okay, so most calculations will come in the form of you write down your number and the given unit. You're pardon me. You're going to then multiply by the wanted unit should be on top. Now you're going to put the number that goes with the wanted unit from your conversion factor. Then the given unit should be on the bottom, and the number with that given unit should also go on the bottom again from the conversion. Okay, notice then your given units will cancel, and in this case you're always going to multiply by everything on the top and divide by every number on the bottom, and that's going to give you, I called it number prime, just means a new number, and now you're going to have the wanted units with it. Okay, so I did the example here. So if we started out with 437 milliliters, right, I multiply, my given units are milliliters, and I know in my conversion that there are 1,000 milliliters in my conversion. Okay, the wanted units are liters, and in the conversion there's 1 liter. So my milliliters cancel. I multiply 437 times 1 and then divide by 1,000, and I end up with 0.437 liters. And in this case, I had 1, 2, 3 sig figs, so I can report my answer in 1, 2, 3 sig figs. Okay, this 0 is not a significant figure, and your conversions never count as a significant figure. Okay. Okay, so now basically we're going to create a flow chart for how to convert between different units. And this is going to come in handy when we start our a couple more units in the future when we talk about stoichiometry, which is at pretty much a heart of what we do here in AP Chemistry and Chemistry. You have to be able to convert between different measurements of matter. Okay, so the first thing you're going to do is when you read a problem, you're going to determine what quantity and units you are given, and then what, not what united, what unit is wanted, okay, and what unit is wanted. This is also an important part to go through the problem and figure out, they may have given you some numbers that you don't need, okay, so make sure you are always searching for two things: the quantity and unit that is given, that you need, and then what unit is wanted. And make sure you just ignore anything else that's not needed for that particular problem. It may be needed later on, but not right now, okay? So once you know what you are given and what you want, you basically then pick from either a list that you're given or from your knowledge, mostly from your knowledge that you're going to remember, if you know a direct conversion between the given and the want, okay? If the answer is yes, awesome, use that conversion. And these are our beautiful one-step problems that are very easy, we love them. Okay, so for example here we have how many centimeters are in 5.0 inches, okay? So I know a direct conversion that 1 inch equals 2.54 centimeters. So I write down my given, which is 5.0 inches. I multiply that by my conversion. Now notice, since inches are the given, then the 1 inch should go on the bottom, okay? And the 2.54 centimeters should go on top because centimeters are what you want, okay? So take a second right now, figure out what would the conversion look like if you were given 5.0 centimeters and you wanted to convert it to inches. Okay, so we're going to move on with the problem. So we have 5.0 inches, okay? I'm going to multiply that by 2.54. Notice my inches are going to cancel. I'm going to be left with the centimeters. So 5.0 inches, or 5.0 times 2.54 centimeters divided by 1 is equal to 12.7 centimeters. However, my answer only had 2 sig figs in it, so I can only report my initial given only had 2 sig figs in it, so I can only report my final answer to 2 sig figs, so I have 13 centimeters as the answer there, okay? Now, not all problems are going to look like this. At some point, you're going to have to, you're not going to know a direct conversion, a direct equality. So basically what you're going to have to do is, this is when dimensional analysis becomes a puzzle. You're going to have to determine what units kind of act as intermediates that connect your given and your want, okay? And this is going to be a multi-step problem. So basically you figure out the order of units you need to use to get from your given to your want. So in this case, we're going to do a problem, how many centimeters are at 100 yards? So I don't know a direct conversion between yards and centimeters. So, but I do know that I can convert yards to feet, and I can convert feet to inches, and therefore I can convert inches to centimeters. So I'm going to, again, I always write down what I'm given. I'm given 100 yards, okay? And I know that there is 1 yard for every 1 yard, there are 3 feet, so my yards cancel here in my first step. Next, now I'm given feet, okay? I need to get rid of feet, so I'm going to put feet on the bottom. I'm trying to get to inches, so I know that in 1 foot, there are 12 inches, okay? And then finally, I need to convert from inches to centimeters, so there is 1 inch per every 2.54 centimeters, so I'm going to then multiply everything, I'm going to go ahead and cancel my units. Yards cancel, then feet cancel, then inches cancel, and I'm left with centimeters. So that is the unit I want. So the unit you want should always be on top in the numerator of your final conversion, okay? So I'm going to multiply everything across on top, so 100 times 3 times 12 times 2.54, and then divide by 1 times 1 times 1, which is just 1, and so that leaves me with 9,144 centimeters. Since my initial answer given of 100 yards only had 1 sig fig, I can only report my answer to 1 sig fig, and the answer should be 9,000 centimeters. Okay, so this was how you do dimensional analysis. You're going to be using this a lot, and I will be checking that you always write down units. Units, units, units. Let your units guide you. Okay, thanks.